The purpose of this video is to help you prepare for the derivatives benchmark, and I would encourage you to get a copy of the blank sheet with all of these 8 derivatives to practice before watching this video. All right, I'm going to go ahead and just work through all of these. This first problem is clearly a quotient rule problem, and so we have dy dx equals, and we know that it's the bottom function, low, times the derivative of the top. This is e to the 2x, so I need to use chain rule because it's going to be e to the 2x times 2, then minus the top left alone, derivative of the bottom, all over the bottom squared. Now on the benchmark, you can certainly leave your answer like this. You'd have to make sure you have parentheses around this negative sign, or at least indicate you're multiplying. It's pretty simple to just clean this up. You just don't want to make any mistakes when you clean it up. So 2e to the 2x cosine x plus e to the 2x sine x, and that whole thing is over cosine squared x. All right, let's go to the next one. In this next one, we've got a sum of different functions, and we need to take the derivative of each one separately. So we look at this first one. Pi sine x, the derivative is pi cosine x. And to make sure we understand that this is the rule that says that if I'm taking the derivative of a constant times a function, that equals the constant times the derivative of the function. So this constant pi stays there, derivative of sine is cosine. This next one is a chain rule where I take the derivative of the outside, cosine pi x, times the derivative of the inside, which is just pi, and I'm going to write it out front. This last one is the derivative of sine pi. Well, sine pi is just a number, so its derivative is 0, which we don't have to write, but I'll just write to make the point. All right, let's look at number 3. A lot of people use quotient rule on this one, but that's the hard way to do it. The easy way is to simply rewrite this as 4x to the negative 20th. And then now we're just using power rule. So now dy dx equals negative 80x to the negative 21st, and we're done. If you do use quotient rule, which I advise against, I want to make sure you do it correctly. And so that would be the bottom times the derivative of the top. The derivative of 4 is 0, minus the top times the derivative of the bottom, all over x to the 40th. Now I would expect that you clean this up. So there's 80 x to the 19th over x to the 40th. A negative from the negative there, and then that cleans up to negative 80 over x to the 21st. And you'll see that it's the same answers we had here, but boy, did we do a whole lot more work. All right, in this next one, we just need to make sure we know the rule for arcsine. So remember that the derivative of arcsine u equals u prime over the square root of 1 minus u squared. Now this 6, remember, that's that rule that says if I have a constant times a function, the derivative is the constant times f prime. So that 6 is going to remain there. So when I find dy dx, I have 6 times. On top, the derivative of the inside is 2x. On bottom, I have 1 minus, must have parentheses here, x squared plus 3 squared. If you like, you can multiply the top and get 12x, but you really don't want to clean up any of the bottom because it'll just look worse. So just keep it looking like this. This is a perfectly fine answer. All right, number 5, even though there's no dot there, you should recognize that I have a function times a function. This is a product rule problem. So the biggest problem with product rule is recognizing that's what it is. But I've got 3 to the x, I've got arctan x, they're being multiplied. It's an product rule situation. 3 to the x left alone, derivative of arctan, 1 over 1 plus x squared, plus the derivative of 3 to the x, which is 3 to the x ln 3, times arctan x left alone. If you want to clean this up, the only thing you would do is write this as a single fraction. The rest needs to just be left as is, and we have a perfectly fine answer right there. Right. This next one, number 6, is the power rule inside and out and chain rule. Dy dx first, our outside function is something taken to the fourth. So that's 4 times that something to the third. We'll put the something back in here. And then the times the derivative of the inside. A lot of students lose points because they forget parentheses here. So I just want to do it wrong for a moment. If I just write times with a dot 49x to the 6th plus 36x to the 5th plus 25x to the 4th. This is incorrect because you'd only be multiplying the outside derivative times this first one and then adding these after. In order to get this one correct, you need parentheses around the whole derivative of the inside. So derivative of the outside times the derivative of the inside. Our next one here, I'm working with a lot of roots here, and it helps to rewrite roots often. So we're going to do 3x to the 1/2 plus x to the 1/3. Remember when we're working with roots, so if I have the mth root of x to the n, that is equal to x to the n over m, or as I like to say, roots are below ground, roots below ground, power lines above ground. Power above ground. So if you think of the power lines out there, that helps. Above ground. Okay, so that's kind of just a way to remember it. So this is a root because the 3 is sitting right here. Our next one, we've got an x cubed. That's a power when there's no number here. It's the square root. And our last one, we can write it as 3 to the 1/2, but we should recognize it's just a number. So when we're ready to take the derivative, we have 3/2 x to the negative 1/2. We're just using power rule. 1/3 x to the negative 2/3 plus 3/2 x to the 1/2 plus 0, because this is simply a constant. Derivative of a constant is 0. All right, our last problem is natural log. It helps to remember that the derivative rule for ln u equals u prime over u. Like in the previous ones, this 5 is where we've got the derivative of a constant times a function, which is simply the constant times f prime. So when I take my derivative, I have 5 times, because 5 is my constant, the derivative of this. I put u prime on top, 3x squared plus 1. I put u on the bottom, x cubed plus x. The only thing you might do is to multiply out that 5. If you do, make sure you distribute it correctly. It'd be 15x squared plus 5 all over x cubed plus x. Or you could have written 5 parentheses 3x squared plus 1 all over x cubed plus x. Any of those work. All right, so any of these 3 would be acceptable forms of your answer. This should help you know what level of expectation, level of difficulty you can expect on the benchmark. Good luck.